using simple commands, put those commands into a file and let the computer do the work for you. No heavy programming is needed. If you can understand basic instructions, you're already qualified to start. So in this course, we'll move slowly, clearly, and practically. We'll start from the absolute basics, what the shell even is, and step by step, we'll build scripts that actually solve real-world problems. By the end, you will not just understand what shell scripts are, you'll be the one to write useful ones with confidence. So here's what we will cover in this course. What a shell is and why people use shell scripts. A quick refresher on basic Linux commands. Writing and running your very first shell script. Using variables and taking input from users. Making decisions using conditions. Repeating tasks using loops. Organizing code with functions. Working with files, texts, and logs. Handling errors and understanding what went wrong. Using advanced features like arrays and menus. Automating tasks like backups and reports. Making scripts interactive and user-friendly. Building real-world projects that you can actually use. Understanding where shell scripting fits in real jobs. Before we dive into the technical details, let me share something exciting that can help you take your cybersecurity skills to the next level and truly accelerate your career. The Cybersecurity Expert Master's Program by Simplilearn is a comprehensive, hands-on learning experience designed for professionals who want to become end-to-end cybersecurity experts and get certified in some of the most in-demand credentials globally. So this is including CEH, AI, CompTIA Security, and CISSP. So in this program, you will gain practical exposure to real-world cybersecurity concepts through integrated hands-on labs, immersive simulations, and exam-focused practice. You will work with industry-aligned tools and environments that mirror real attack and defense scenarios, covering areas like ethical hacking, system penetration, testing, network security, malware threats, and AI-powered threat detection. Throughout the journey, you will build a strong foundation across cybersecurity fundamentals, cloud security, compliance, and advanced defense strategies used by modern organizations. What makes this program even more powerful is its strong focus on certifications and career readiness. You will receive 6 months of complimentary access to the official CEH V13 AI labs along with EC Council course and exam voucher. The curriculum is fully aligned with the latest certification exams, helping you prepare with confidence through simulation tests and expert-led live sessions. Alongside technical mastery, Simplilearn supports your career growth through Job Assist Plus, which includes resume building and recruiter visibility, and a 6-month IIM Jobs Pro membership designed to help you get noticed by top hiring companies. You will learn through live interactive online classes led by experienced cybersecurity professionals and earn an industry-recognized program certificate by Simplilearn, adding strong credibility to your profile. By the end of this 4-month program, you will not just hold certifications, you will have the skills, confidence, and practical exposure needed to tackle real-world cybersecurity challenges and step into high-impact roles across industries. So before we start off, here's a quick quiz question. So what is a shell script? Is it A, a video game, B, a file that contains instructions of a computer, C, a type of hardware, or D, a text editor? Have you ever found yourself doing the same repetitive task on your computer, whether it's organizing files, renaming them, or performing maintenance work? What if I told you that there's a way to automate all of that? Maybe something as simple as renaming files, organizing your photos, or managing a bunch of servers. Well, today we're going to learn a powerful way to automate those repetitive tasks, shell scripting. So what exactly is shell? Imagine you're trying to give instructions to a robot in your house. Instead of telling the robot each task individually, you give it a list of tasks and it does them for you. That's exactly what shell is for your computer. It's a way to communicate directly with your operating system using commands. Shell is a command line interface where you type commands into a terminal and the computer follows those commands to execute tasks. It's like sending your computer a series of secret codes that it understands, and in return, it carries out the tasks you have asked it to. Think of it as a translator between you and the operating system. Here's why you should learn shell scripting. Now, you may be wondering, why should I learn shell scripting? Imagine you're a chef in a busy kitchen and have to chop vegetables, boil water, and stir the sauce over and over again. Wouldn't it be great if someone automated some of that for you? Imagine if your oven could start itself or your vegetables could chop themselves. Shell scripting is like having that automation in your digital kitchen. It allows you to automate tasks on your computer, saving you time and effort, just like having a robot assistant in the kitchen. Learning shell scripting can help you automate repetitive tasks, manage files, run programs, and control systems more effectively. It opens up career options in areas like DevOps and IT system management, where automation is key to saving time and resources. Now let's talk about how you can set up a Linux environment. Think of this like setting up a kitchen to cook your automated meals. You need the right tools and space to do it efficiently. In the world of shell scripting, that space is your Linux environment. You can set up a Linux environment in several ways. If you're on Windows, you can use WSL, which allows you to run a full Linux environment within your Windows machine. It's like creating a mini Linux kitchen inside your home. Alternatively, you can use a virtual machine or set up a cloud-based environment like AWS or Azure. No matter which option you choose, having access to a Linux environment is essential because it's where you will practice shell scripting. Linux is a go-to operating system for scripting and server management. We shall now speak about code reusability and maintenance. Imagine you're baking cookies. Every time you bake, you reuse the same recipe over and over again. That's exactly how code reusability works. Once you write a script, you can reuse it for different tasks, reducing the effort required each time. But just like a baker keeps the kitchen clean and organized, you also need to maintain your scripts. This means updating them when new tasks come up, adding comments to explain what's going on, and fixing any issues that arise. Maintaining your scripts ensure that they remain efficient and adaptable as your needs change. Reusability and maintenance saves your time and makes your scripts more robust. We shall now move on to common mistakes that you should avoid. Have you ever followed a recipe and forgotten an ingredient? It can ruin the whole dish. In scripting, one of the most common mistakes is hard coding values. This is like saying my recipe always needs exactly 1 cup of sugar without being able to adjust it. Instead, you should use variables which act like adjustable ingredients so you can change them as needed. Another mistake is not validating user input. Imagine a dinner guest asking for something that they don't like. If you don't check, you might end up with a bad meal. Similarly, in scripting, if you don't check the inputs your script receives, it could break unexpectedly. Always validate inputs to prevent errors. And don't forget debugging. This is like checking your ingredients before cooking. By anticipating potential problems, you can prevent your scripts from crashing. Let's move on to learning resources and practice platforms. So now that you're all set to start scripting, where do you go to practice? Learning to script is like learning to bake. You start with simple recipes and build your skills over time. There are plenty of online platforms where you can learn shell scripting, like Codecademy, Free Code Camp, and Udemy. These platforms offer interactive tutorials where you can practice and experiment with real-world problems. Once you're comfortable with basics, you can turn to GitHub and Stack Overflow to connect with other developers and find open source projects where you can contribute. These platforms are great places to practice and interact with other learners, so you can keep improving your skills. So as we wrap up, let's talk about what's next for you in shell scripting. Remember, just like learning to cook, shell scripting is a skill that improves the more you practice. Start by writing simple scripts to automate basic tasks. As you get more comfortable, you can move on to advanced topics like file permissions, process management, and even integrating your scripts with other tools. The skills you develop through shell scripting will help you manage systems, automate workflows, and make your digital life much more efficient. As you continue learning, explore advanced automation frameworks and cloud-native scripting to further enhance your skills and open up more career opportunities in fields like DevOps and system administration. So let's start by understanding how to navigate around the Linux file system. Think of it like exploring a large city where every directory is a building and every file is a room inside that building. So to get around, you need to know where you are and how to move from one place to another. Let's start off with the first command, which is the ls command. So this command lists the files and the directories in your current location. Imagine it as the city map. It shows all the buildings around you. So you can even customize it to show details like file sizes or modification dates. For example, when you type, so I will be typing the first command here, ls, you'll get a simple list of everything in your current directory. So to see more details, use the L flag for long listings. So this shows you the file permissions, ownership, size, and more. So I'll just show you how it's done. So as you can see, it shows you the file permissions, ownership, and size. We shall now move on to the next command, which is the cd command. So it's short for change directory, and this command helps you navigate to a new directory. Think of it like taking a shortcut to the next building on your city map. So for example, I'll show you. One second. So I shall type change directory and downloads. So this command takes you to the downloads folder inside your current directory. So to go back to the previous directory, you can use, so by using cd followed by 2 dots, it moves you up one level in the file system, like going back to the main street from a side alley. Next, we shall talk about the pwd command. So this command tells you your current location in the file system. It's like looking at your GPS to see exactly where you are on the map. So to check your location, just type So this will print the full path of your current directory, as it has been shown over here. Next, we shall move on to file operations. Now that we know how to get around, let's talk about some essential file operations. So these are the tools that you will use to create, move, copy, and delete files in your file system. Now we shall speak about the cp command. So the cp command is used to copy files or directories. So think of it like making a photocopy of a document. You're creating a duplicate while the original remains intact. So before showing you how to execute the cp command, I will first create two different files. I will use the touch keyword to create two different files. So file 1.txt, and then I will also create the second file, which is file 2.txt. So as you can see, two files have been created in the directory. So now we shall move ahead and copy the first file into the second file. We shall now copy the first file into the second file. On using this particular command, you can copy the contents in file 1 to the file 2. Now let's talk about the move command. So the mv command moves files or directories, or it can rename them. So it's like picking up a document and placing it in a new location or even renaming them. So in order to rename an old file, this is the command you use. So as you can see, the file has been renamed from file1.txt to file.txt. So in order to move a file to a new directory, here's what you're supposed to do. So I have moved the file.txt to a different location. Now we shall speak about the remove command. So the rm command is used to delete files. It's like throwing away a document. But be careful though, once it's gone, it's really hard to get it back. So I'll show you how to execute that. So as you can see, the file has been deleted from the directory. So if you want to delete an entire directory and its contents, use the R flag. So in order to show you how to delete a file, I shall first create a file. So if you want to delete a directory, I'll first go ahead and create a directory. So I shall go ahead and remove the directory using the R command, and I will be deleting the directory called my folder. So as you can see, the directory has been removed. Now we shall move on to the make directory. So this command creates a new directory. Think of it like building a new folder to store your files. So you can even create multiple directories at once. I will show you how to do it. I shall use the command name, then I shall add some folders here. So as you can see, multiple folders have been created. Next, we shall move on to viewing file content. Sometimes you just need to peek inside a file without opening it fully. So Linux gives you several commands for viewing file content, so let's explore them. Firstly, the cat command. So the cat command displays the entire content of a file. It's like opening up a book and reading it from cover to cover. So I shall show you how to implement this. Before that, I'll go ahead and create an empty file using the touch command. So now that a file has been created, I will go ahead and open this file using the cat command. So in order to copy some content into the file, here's what we will do. I shall use the echo command. Within brackets, I will paste the content which I want. So let me go ahead and do that. Then we shall follow up that by the file name in which we are going to copy the content into. So let's move ahead and view the file again using the cat command. So this will show you the entire content of the file1.txt in the terminal, as you can see here. We shall now move on to the next command, which is the less command. Sometimes a file is just too large to read it all at once. So in those cases, less is your friend. So it allows you to scroll through the file, similar to flipping through a textbook. So I'll go ahead and show you how to implement less. So we use the less command followed by the name of the file. So with less, you can scroll up and down through the content using arrow keys or spacebar to go down a page. About the head command. So if you want to see the first few lines of a file, use head. So it shows you the top of the file like reading the introduction of a book. So as you can see, I've used the head command followed by the file name. So by default, head shows you the first 10 lines of a file. So if you want to change that number, you can use the n option. So I'll go ahead and show you how it's done. So since I've attached a paragraph here, it doesn't really execute the command. So I will go ahead and add some new content into the file. So I will do that as follows. So now let's go ahead and try executing it with the command. So I shall be using the first 5 lines and then the name. Yeah. So as you can see the first 5 lines. Now let's move on to the next command. Just like head, but for the last few lines of a file. So this is useful if you want to see the most recent content in a log file or a document. So I'll use the tail command followed by the name of the file. So as you can see the last few lines in the file. So you can also use the F option to follow a file in real time. So this is especially useful for logs. Now we shall move on to permissions and ownership. So it is built with strong security features, and one of the most important aspects is controlling who can access and modify. So this is where file permissions and ownerships come into play. This is the chmod command. So this command changes the permissions of a file or directory. So it's like deciding who can read, write, or execute a file. On using this command on the file, it gives the owner full access, which is read, write, and execute, as well as read, execute access to everybody else. You can also use symbolic notation instead of numbers. I'll go ahead and show you that. Plus x, I. Let's move on to the next command, which is chown. So the chown command changes the owner and the group of a file. So it's like transferring ownership of a document to somebody else. So I'll go ahead and show you an example. So I'll use the chown command followed by the user and the group and the name of the file. So this changes the owner of the file to the user and a group. Now let's move on to getting started with shell scripts. So imagine you want your computer to do something for you, like sending an email, backing up files, or even checking the weather. So instead of manually doing each task every time, we can write a shell script to automate it. So a shell script is simply a file that contains a series of commands that the shell can execute. So let's start by creating your first shell script, a simple one that greets you. So for that, you will have to open your terminal and use the touch command to create a new file called greeting.sh. So I'll go ahead and do that using the touch command, and the name of the file will be greeting.sh. So as you can see, a file has been created. Now let's learn to open the file. So use a text editor like Nano or Vim to open the script file. Let's use Nano for simplicity. So I'll go ahead and show that to you. Nano followed by greeting.sh. So as you can see, we are inside the editor now. If you want to exit from the file, you can just do Ctrl+X. That has been done. Now let's write our first script inside the file. So you will have to go ahead and type the following. So now that this has been typed into the editor, you will finally press enter. So before that, we will have to save the file. After you type Ctrl+X, you will get an option here where they're asking you to save modified buffer. You will go ahead and press Y. Now in order to escape the editor, type Ctrl+X. So the bin bash part of the top file is known as the shebang. So it tells the system to use the bash shell to execute the script. So echo is a command that prints the text inside the quotation marks to the terminal. So regarding saving and closing the file, once you've written the script, save and close the editor. So in Nano, you're supposed to press Ctrl+X and then press Y to confirm saving, and finally press enter. This has been shown to you already. We shall now learn about executing bash scripts. So you've just written a simple script, but now you need to run it. So in order to do so, you need to tell your computer to execute the script. So before running the script, you need to give it permissions to execute. So you can do this with the help of the chmod command. So I'll go ahead and do that now. Chmod +X followed by the name of the file. So now that your script is executable, it's time to run it. So to execute it, use the following command, which is // followed by the name of the file. So when you run this, your terminal will display hello, welcome to shell scripting as it's shown here. So if the terminal says permission denied, ensure that you have executed the permissions with the chmod +X. I shall now brief you on the role of shebang. So the shebang is a critical part of every shell script. So it's a special line that tells your system how to interpret the script. So let's break it down. So now the hash part along with the exclamation mark is called the shebang. So it's a special character sequence that indicates that the path to the interpreter is used to run the script. It specifies that the script should be executed using the bash shell. So bash is a popular shell in the Linux system, and it's used to run most of the shell scripts. So the shebang is necessary because it allows you to run your script by simply typing dot and slash. And there is no need to specify the interpreter each time. In programming, comments are a way to add notes or explanations in your code without affecting its execution. So comments are like little reminders you leave for yourself in your code, making it easier for you to understand it later. In bash, comments start with the hash symbol. Anything written after hash is going to be ignored by the system when executing the script. So it's just for humans to read. Speaking about single line comments, any line starting with a hash is a comment. So why should you be using comments? If someone else is reading your script, or even if you're months later, comments can help you explain what each part of the script does. It also helps with debugging. So you can comment out parts of the script to temporarily disable them while testing other sections. Organizing your code. Large scripts can become messy. So use comments to divide the script into sections, making it more readable. With these basics, you're now ready to start writing and executing simple shell scripts that can automate tasks on your system. We shall now learn to define and use variables. So in programming, variables are like containers that hold information. So in shell scripting, variables store values that can be used throughout the script. For instance, imagine you have a box labeled name, and inside that box you place your actual name. So that's essentially what variables do. They store data that you can use whenever needed. In Bash, defining a variable is simple. So I will show you how to do it. You type name followed by the name that you want to enter. I shall use John over here. Make sure that there is no space in between the equal to sign and the double quotes. So here, name is the variable and John is the value stored in that variable. Now we shall move on to how to use a variable. So in order to access the value stored in the variable, use the dollar symbol before the variable name. So I shall go ahead and show you how to do it. For doing that, you will have to use the echo keyword followed by hello, dollar sign, and the name. So as you can see, we've got hello John as the output. So as I said, when you run the script, the shell replaces dollar name with the actual value, which is John. So you see the greeting hello John printed on the terminal. We shall now learn changing the value of a variable. So variables can be updated just like changing the contents of a box. You can reassign a new value to the same variable. So I shall go ahead and replace the name with the name Alice. Make sure that there's no space between the double quotations as well as following the name. I shall use the echo command again, followed by hello. So as you can see, the output has been updated to hello Alice. So this flexibility is useful for handling dynamic data during script execution. Like I said, you should make sure that there are no spaces around the equal to sign. So when defining a variable in Bash, ensure that there are no spaces around the equal to sign. For example, this will throw an error. So let me go ahead and leave a space between the equal to sign. Yeah. So as you can see, it says command name not found. We shall now move on to reading input from users. So sometimes you want your script to interact with the user, asking for input and using that input in real time. So this is where the read command comes in handy. The read command allows you to capture user input and store it in a variable. So I shall now show you how to use read in order to get an input. So go ahead and use the echo command, and within the brackets, what is your... We shall now type read name followed by the echo command hello dollar sign the name. Yeah. So in this example, the script will prompt the user with what is your name and wait for their input. So once the user enters their name, it stores it in the name variable and greets them with their name. So I will go ahead and show it to you. So what is your name? I shall go ahead and type Alice. It stores the name in the variable and greets them with the name Alice. We shall now move on to multiple inputs. You can read multiple values at once and assign them to different variables. So as you can see, I have used the echo command followed by enter your first name and your last name. Then I use the read command followed by the first name, last name. So for example, if the user types John Doe, it assigns John to the first name and Doe to the last name. So I'll go ahead and show you this. So here it's asking me to enter the first and the last name. So I shall go ahead and type John. So as you can see, I have received the output as hello followed by the first name along with the last name. You can also give a variable default value if the user doesn't input anything. So I've shown the code here as follows. So here you can see the output. The code asks you to enter your favorite color. So I'll go ahead and type blue. And then I can see the output, your favorite color is blue. Let's move on to environment versus user-defined variables. Now let's differentiate between two types of variables that you will encounter in shell scripting. They are user-defined variables and environment variables. Here's what is user-defined variables. So these are variables that you can create in your script to store specific values. They are used within the script and do not persist once the script finishes running. So I'll go ahead and show you an example. I shall type user is equal to John. Also have to make sure that there's no space between the equal to's. Then use the echo command and type hello followed by dollar sign and the user. So in this case, user is a user-defined variable. It only exists during the script's execution. We shall now move on to environment variable. So these are system-wide variables that are set by the system or by the user to control the behavior of the shell or operating system. So environment variables are used for system-wide settings, like the location of important files or directories. I'll go ahead and show you an example. For example, the home directory. So home indicates the home directory of the current user. Then we have path. So path is a list of directories where executable programs are located. So in order to see all of the environment variables in your system, use the printenv command. So I'll go ahead and show you that. Printenv. So as I said, you can see all of the environment variables in the system. We shall now move on to setting environment variables. So you can create environment variables temporarily for the duration of the session by using the export command. For example, export user to. So this sets the variable user as an environment variable, making it easily accessible to other processes. So here are the differences between an environment and a user-defined variable. So user-defined variables are only available within the script or a session, while environment variables can be accessed by any process running on your system. Environment variables can be persistent across different sessions if set in specific files, while user-defined variables disappear after the script finishes. You can access environment variables just like user-defined variables by using the $ symbol. I'll go ahead and show that to you. So we use the echo command again, followed by your home. So this prints the current user's home directory, like home followed by the user. You can modify an environment variable within your script by making the export command, but to make permanent changes, you would need to add the export command to configuration files like .bashrc or bash profile. You have learned to use variables to store and manipulate data in your scripts, interact with users for inputs, and distinguish between user-defined and environment variables. So these foundational concepts are crucial as we move into more complex shell scripting tasks. We shall now move on to conditions and decision making. Conditions allow your script to make decisions based on certain criteria, just like how you make decisions in real life. For example, if it is raining, you might take an umbrella. Conditions allow your script to make decisions based on certain criteria, just like how you make decisions in real life. For example, if it's raining, you might take an umbrella. Otherwise, you would leave it at home. Shell scripting uses if-else statements to make similar decisions. An if statement checks a condition, and based on whether it's true or false, it executes different code. I'll go ahead and show you an if-else syntax. So as you can see, I've typed out the code here. I shall now tell you how this works. So the condition $weather is equal to rain checks if the value of the variable weather is equal to rain. So if this condition is true, the script will output take an umbrella. So if the condition is false, the script will output no umbrella needed. So as you can see, the output here is no umbrella needed. We shall now move on to conditions and decision making. Starting off with, we have if-else statements. So conditions allow your script to make decisions based on certain criteria, just like how you make decisions in real life. So for example, if it's raining, you might take an umbrella. Otherwise, you will leave it at home. So shell scripting uses if-else statements to make similar decisions. An if statement checks a condition, and based on whether it's true or false, it executes different code. So I'll go ahead and show you a basic if-else syntax. So this is the code for the same. I shall now tell you how this works. So the condition weather is equal to rain checks if the value of the variable weather is equal to rain. So if the condition is true, the script will output take an umbrella. And if the condition is false, the script will output no umbrella needed. So we'll move on to an example with user input. So let's say we want to ask a user for their age and check if they are eligible to vote. So I'll go ahead and type the code for that. So as you can see, I've typed this code. Over here, the condition age GE18 checks if the user's age is greater than or equal to 18. So the GE here stands for greater than or equal. So based on the user's input, the script can either print, you can vote, or sorry, you can't vote yet. So let's go ahead and execute this. Let's just say I enter my age as 23. It gives us the output of you can vote. So let's go ahead and execute the same code again. So if I enter my age as, let's say 16, here the output is sorry, you can't vote yet. We shall now move on to elif ladder. So when you have multiple conditions to check, instead of stacking multiple if-else statements, you can use elif, which stands for else if. So this lets you check several conditions one after another. So I'll go ahead and show you a basic elif syntax. So I'll go ahead and type in the code as follows. So this example checks 3 conditions. Firstly, if the age is 18 or more, it prints you are an adult. So if the age is between 13 and 17, it prints you're a teenager. Finally, if the age is less than 13, it prints you are a child. So here's how elif works. So it lets you check multiple conditions one by one, and it stops once a true condition is found. If none of the conditions are true, then the else block is executed. So I'll go ahead and execute that for you. We shall now move on to test and syntax. Test command is used in shell scripting to evaluate conditions. So it's often written as within square brackets condition, which is shorthand for test condition. This command helps you compare values and check for various conditions like file existence, strings, and numbers. Using test for conditions is as follows. So here, f checks if the file.txt is a regular file. If it exists, it prints file exists. So here, as you can see, the output is file does not exist. We shall now move on to checking for directories. You can also check for directories using the d command. The code is as follows here, and here the output is directory does not exist. Moving on, we have comparison operators, which are strings, integers, and files. To make effective decisions in your scripts, you will often need to compare values. Bash provides several operators for comparing strings, integers, and files. So we shall now talk about string comparison. Firstly, we have equality. It checks if two strings are equal. Secondly, we have inequality. So it checks if two strings are not equal. So I'll show you a small example. So we shall go ahead and type name is equal to Alice, followed by an if statement where if $name is equal to. So as you can see, the output is hello Alice. Greater than or equal to, less than or equal to. So I'll go ahead and show you an example for the same. So here the output is 10 is less than 20. We can also do file comparison. You can also test file properties. For example, there's existence where E checks if the file exists. Then there's regular file where F checks if it's a regular file. Then we have directory where D checks if it's a directory. We have writable where W checks if the file is writable. So I will show you an example which uses all of the above commands. So I've gone ahead and executed the code here. So I'll give you a small summary of the file operators we used. So E stands for exists, where F stands for regular file, D stands for directory, R stands for readable, and W stands for writable. Lastly, X stands for executable. So this particular chapter covered the key conditional and comparison commands in shell scripting. So these tools allow you to control the flow of your scripts and make decisions based on dynamic outputs, file states, and conditions that you define. We shall now move on to the next chapter, which is on loops in shell scripting. This includes for, while, and until loops. So in shell scripting, loops help automate repetitive tasks, save time and effort. So let's explore three types of loops: for, while, and until. Firstly, we have the for loop. So the for loop is one of the most commonly used loops. So it helps you repeat a set of commands for a specific number of times or over a list of items. So the simplest way to use a for loop is by specifying a range of values. So I'll go ahead and show you an example for the same. Gone ahead and executed the code. So as you can see, the loop printed numbers from 1 to 5. So it's like telling the script, repeat the following command 5 times, once for each number from 1 to 5. We shall now move on to looping over directories. So you can use a for loop to process files in a directory. So I'll show you an example for the same. So for file in star.txt along with the do command. So this will loop through all of the .text files in the current directory and print their names as shown in the output. We shall now move on to the while loop. So the while loop is used when you want to repeat a set of commands as long as a specific condition is true. So it continues executing as long as the condition evaluates to be true. So let's say we want to print numbers till we reach the number 5. Let me go ahead and show you the code for the same. So here we've used count as well as while. So the loop keeps running until the count reaches 5. So it starts at 1, prints it, and then increments it by 1 each time. So you can see the same in the output. We shall now move on to until loop. So an until loop works similarly to a while loop, but it continues until a condition becomes true rather than while a condition is true. So in other words, it's the opposite of a while loop. So let's use until to print the numbers from 1 to 5. So the code here, it's as follows. So this is a simple example which uses the loop. So as you can see, the loop will continue running until the count is greater than 5. So the key difference between while and until is how the condition is evaluated. So the until loop runs as long as the condition is false. We shall now move on to looping through arrays and strings. So sometimes you might need to loop through a list of items or the elements in an array. So in Bash, arrays can hold multiple values and looping through them allows you to process them individually. So you can use the for loop to iterate through each element of an array. So I'll go ahead and show you a simple example. So here we have 3 fruits, which is apple, banana, and cherry. So as you can see in this example, fruits is an array containing 3 items. So the for loop iterates over each item in the array and prints it. So as you can see, the final output is I like apples, I like bananas, and I like cherries. We shall now move on to looping through a string. So you can loop through a string character by character, like scanning a sentence for specific words. For example, so as you can see, the fold w1 command breaks the word into individual characters, and the for loop prints each letter in a new line. So as you can see in this example, the characters in the word hello have been printed in 5 different lines. So H is printed in one line, E is printed in the second line, L in the third, the other L in the fourth, and O in the fifth. So we shall now move on to break and continue statements. While loops allow us to repeat tasks, sometimes we need to break out of the loop or skip certain iterations. So this is where the break and continue commands come in. The command is used to exit a loop prematurely, no matter where you are in the iteration. So I'll prove it to you with the help of an example. Loop, the script will print numbers from 1 to 4. So when it reaches 5, it will print breaking the loop at 5 and then exit the loop immediately. Moving on to the continue statement. The continue command is used to skip the current iteration of the loop and move to the next one. So here, when the I equals 3, the script will print skipping number 3 and move on to the next iteration, skipping the echo for 3. So this is seen in the example as shown. So let's move on to real-world looping scenario. Let's take a real-world example where you need to check if files are backed up correctly. So you want to loop through a list of files, check their size, and if any file is too large, let's say above 100 MB, you will log it. So here's an example scenario. So over here, statc and $file retrieves the size of each file in the bytes. So if the file size is greater than 100 MB, it logs a warning in largefiles.log. So if the file is within the size limit, it prints a confirmation. We shall now move on to the next chapter, which is functions and modular scripting. So in shell scripting, functions are like small reusable blocks of code that perform a specific task. You can write a function once and then call it multiple times in your script, making your code more organized and easier to manage. To define a function in Bash, we use the following syntax. So as you can see on my screen, this is the syntax you use to define a function in Bash. So I'll go ahead and execute an example for the same. So this is a function that prints a greeting. Next, we will move on to calling the function. So after defining the function, you can call it by simply writing its name followed by parentheses. So as you can see here, the output is hello, welcome to shell scripting. Now we shall speak about functions which are great for avoiding repetition. For example, if you wanted to print a greeting message multiple times in different places, you could call the greet function instead of repeating the echo command. Next, we shall move on to function parameters and return values. In addition to performing tasks, functions can accept input and return values, making them even more powerful. So this is like giving the function some data to work with and getting the result back. Now speaking about function parameters, when calling a function, you can pass data into it as parameters. So inside the function, you can access these parameters using special variables like $1, $2, and so on, where $1 is the first argument and $2 is the second, and so on. So I'll show you a small example for the same. So as you can see, the output here is hello Alice. So in this case, Alice is passed as the first argument to the greet function. So the $1 inside the function represents Alice, so the output is hello Alice. Now we shall talk about using multiple parameters. So you can pass multiple arguments into a function and then access them using $1 and $2. So I'll go ahead and show you an example. So I have picked two names for the same, which is Alice and Johnson. Let me go and execute this. So as you can see, we've received the output as hello Alice Johnson. Moving on to returning values from functions. So in Bash, functions don't return values like other programming languages. However, you can use echo to output a result and capture it when calling the function. So in this example, the add function calculates the sum of two numbers and outputs the result. So we capture this result in the variable result using dollars and parentheses and then print it. Using source and external script files. So as your scripts grow, you will want to break them into smaller, more manageable pieces. So this is where source and external scripting files come into play. Instead of writing all of your functions and code into a single file, you can organize them into separate files and source them into your main script. I shall now show you how to use source to include external files. So the source command allows you to include and execute code from an external file. This is useful for reusing functions and variables across different scripts. For example, first you create a separate file called functions.sh with some functions. Now that that's done, in your main script, use source to include the functions.sh file. So as you can see, we've gotten the output as hello Alice. When you run mainscript.sh, it will source functions.sh and execute the function. So why do you have to use source? You use it for code reusability. where you can write common functions in one file and source them in multiple scripts. It helps to organize your code into smaller files, making it easier to maintain. External script execution. You can also execute an external script as a standalone program. To do this, ensure that the script is executable and run it like this. So as you can see, this has been executed. Next, we will move on to file handling and text processing. So in shell scripting, redirects are used to control where the output of a command goes and where the input comes from. Think of them as pipelines that direct the flow of data between commands and files. So let's speak about redirecting output. So the less than symbol is used to redirect the output of a command to a file, overwriting any existing content. So for example, this particular symbol displayed on my screen, the output to an existing file without overwriting its content. So I'll show you a small example for the same. As you can see, I've executed the code. So this will add welcome back to the end of the greeting.txt, leaving the previous content intact. We shall now speak about redirecting input. So the greater than symbol is used to redirect input from a file to a command, like feeding a file into a program. So for example, so it says that there's no such file or directory. So let me go ahead and just create a new file called as names. So I think this should do the job. Yeah. So this will read the contents of names.txt and feed it into the sort command to display the sorted contents. Now speaking about redirecting error outputs. So errors are typically displayed in the terminal, but with this command, you can redirect error messages to a file. So I'll show you this with an example. So if the ls command fails, because the directory doesn't exist, the error will be written to an error log instead of being shown in the terminal. Let's move ahead and speak about pipes and chaining commands. So pipes allow you to send the output of one command directly into the input of another command. So this is extremely useful when you want to combine multiple commands into a single workflow. A pipe connects the output of one command into the input of another, like linking two pipes together. So here's a small example for the same. Yeah. So this will list the files in a long format and then use grep to filter and show only the files containing txt in their names. Let's now speak about chaining multiple commands. You can chain multiple commands together using pipes, and then view the top 5 with head. These are the files which have been displayed. The part here lists the files. Here sorts the list of the files and shows the first 5 files in the sorted list. So I shall now show you how to use these two commands. It is used to run the second command only if the first one succeeds. Used to run the second command only if the first one fails. In other words, it returns false. After executing this command, the attempt was made to create a folder, and depending on whether it succeeds or fails, it will print the corresponding message. So that was created successfully, so there are no issues. We shall now speak about some basics, which are grep, sed, and awk. So these are powerful tools for searching, modifying, and processing text in files. So let's break them down. Let's talk about the grep command, which is also the global regular expression print. So grep is used to search for patterns within text. Think of it like a search function for your files. So it says that there is no file.txt. So I'll go ahead and create one. Now let's go ahead and create one called file.txt. Yeah. Now we shall go and execute the grep command. Yeah. So this will search for the word hello in the file.txt and print all the lines that contain it. So let's go and add some content within the file.txt. So let's just add hello. Come to shell scripting, and this is contained in file. Yeah, so this has been done. Let's now go ahead and execute the grep command. I'm assuming that the lines contained in file.txt is a single line, so that's the reason why it's not able to print all the lines which contain the word hello. So we shall now move on to case insensitive search. So on executing the command, this is the output we get. So it will match hello in all smalls or even if it's in all caps. So this will search for the word error in all of the log files in the current directory. So let me try and show that. So echo error. I'll just go ahead and change the sentence within the file file. Yeah. So let's go ahead and execute this command again. Yeah. So as you can see, when the command was executed, it searched for the word error in all of the log files in the correct directory. So this is inclusive of the text file. We shall now move on to the sed command, which is also called as the stream editor. So sed is used to perform basic text transformations on an input stream, which is a file or an input provided by a pipeline. For example, you can replace text. I'll go ahead and show it to you. File. So as you can see, new text in each line. Let's move on to in-place editing, which modifies the file directly. Now we shall learn to delete lines. So this particular command here is supposed to delete the second line from file.txt. So as you can see, the second line has been deleted and we're left with hello, welcome to shell scripting. Then we have AWK, which is pattern scanning and processing language. So AWK is a powerful tool for text processing, especially useful when dealing with columns of data. So for example, if you want to print specific columns, this is the line of code that you're supposed to be executing. Yeah. So as you can see, it prints the first and third columns of each line in file.txt. So as you can see, the word hello is printed and the word is has been printed at the bottom. Now speaking of values in a column, so it sums up the values in the second column of file.txt. So as you can see, you have obtained the sum of the values in the second column of file.txt. Now we shall speak about filter based on condition. So this is the code which we're executing for filter based on condition. So as you can see, this prints the first and the second columns, but only if the value in the second column is greater than 100. Let's now move on to logging and appending to logs. So log files are crucial for tracking events, especially for troubleshooting and monitoring processes. So bash scripts often include logging mechanisms to capture the script's activity and potential errors. If you want to redirect output to a log file, you can log the output of a script to a file using redirection. So this is the line of code for the same script.log. Yeah. So let me go ahead and run this. So this will create a file called script.log with the text script started. Now if you want to append to log files, to keep adding new log entries without erasing previous ones, you're supposed to use this particular operator. So you're doing this in order to append to the log file. So for example, we use echo followed by script running at $ with the date, and then you will have to mention the log file. So let's go ahead and execute this. Okay. Yeah. So this will append the current date and time to the log file, allowing you to track when the script ran. So as you can see, the date and the time has been shown. Now we shall move on to logging errors. So redirect error messages to a separate log file to keep track of any issues. So for example, you can use this command. So we have command that might fail, and then we have our error.log. So let's go ahead and execute this. Yeah. So this captures error messages, which are also standard error represented by 2, and appends them to error.log. Then we shall create a log function. You can create a reusable function to log messages with a timestamp. So I'll go ahead and show that to you. So we have two different log messages here, where the first one is script started and the second one is process complete. So let's go ahead and execute this. So in conclusion, this chapter introduced key concepts for handling and processing files in shell scripting, including redirects, pipes, text processing tools, and how to handle logging and append to log files. So these tools and techniques help make your scripts more powerful, flexible, and useful in the real-world applications. Let's now move on to error handling and debugging. So in shell scripting, error handling is crucial to ensure that your script behaves as expected and handles unexpected situations properly. So every command that runs in a script returns an exit status, which indicates whether it was successful or it failed. For example, when you run a command like ls to list files, it will return an exit status of 0 if it succeeds and 1 if the directory doesn't exist. So as you can see, the $? variable stores the exit status of the last command executed. If the directory doesn't exist, then the $? will output a non-zero value, typically 2 for file not found. So you can use this particular symbol in your script to check if your command has succeeded and take action based on that. So for example, here if the cp command succeeds, the script will print file copied successfully. And if it fails, it prints error copying the file. So let's go ahead and execute this and see what we get as the output. Yeah. So here it shows that the file has been copied successfully. So there are no errors. So if it would have failed, it would have printed copying the file. So let's move on to the set E and set X functions. So shell scripting provides some powerful flags to help debug scripts and manage error handling. So let's talk about set E. So the set E command causes the script to exit as soon as any command fails. That is when a non-zero exit status is returned. So this helps prevent further commands from running when an error occurs, making it easier to track when things go wrong. So for example, I'll go ahead and execute the code now. So I've executed the code here. So as you can see, the non-existent directory fails because the script exited immediately and it will not run. Let's now move on to set X, which is the debugging mode. So the setX flag enables debugging mode where the shell will print each command along. So the setX flag enables debugging mode where the shell will print each command along with its arguments before executing it. This is useful for tracking how the script is being executed and what values are being passed to the commands. So I'll go ahead and show you an example. Let me go ahead and change the name of the user. Yeah. So with setX, you will see the actual commands being executed, such as +echo. So this is a debug message. This helps you see exactly what the shell is doing, making it easier to debug issues. Let's now move on to trapping errors and signals. Sometimes you might want to handle specific errors or signals, like when the user interrupts a script with Ctrl+C. This is where the trap command comes in. We shall now learn to use trap to handle signals. The trap command allows you to specify actions when a signal is received. Some of the common signals include sigint. This is triggered by Ctrl+C. It's also known as the interrupt signal. Then we have sigterm, which is the termination signal. Then we have ERR. This traps that cause non-zero exit statuses. So I shall show you a simple example which uses all of these signals. This is the line of code for the same. So this particular script will print a message and exit if the user presses Ctrl+C during execution. So let me try doing that. And let's just say I press Ctrl+C. Yeah. So as you can see, a message has been printed like script interrupted by the user, and then it has been exited. So let me go on. Okay. Let's now speak about trap for errors. So you can trap errors in your script to perform cleanup or other actions. For example, so here we use the trap command along with. So if any command fails or it returns a non-zero exit status, the trap will activate, displaying an error occurred, exiting. So as you can see, we have received the same message here. So along with that, you will also get status 1. So the status here, which has been displayed, is 1. Now we shall learn how to handle missing files or invalid output gracefully. So when dealing with user input or file operations, you might encounter situations where the file doesn't exist or the input is invalid. So rather than letting your script fail, it's good to practice to handle these scenarios gracefully. So here's how you can handle missing files. You can use if statements to check if a file directory exists before attempting to perform actions on them. So for example, we have two statements here, which is file exists and the second one is file not found. Please check the path. So let's go ahead and execute this. Yeah. So since we already created a file in the name of file.txt, we've got the message file exists, proceed with the operation. So this particular command was checking if file.txt exists before attempting to operate on it. So if it wouldn't have existed, the script would notify the user instead of throwing an error. We shall now move on to validating user input. So when accepting a user input, you might want to validate that it meets a certain criteria. For example, if you're asking for a number, you can check if the user entered a valid integer. So for example, again, we have two different statements here, which is you entered a valid number and the second one is invalid input. Let's go and execute this. So it's asking us to enter a number. Let me go and enter 3. So as you can see, the output received is you have entered a valid number, which is 3. So let me go and execute the same code again and enter something invalid. Let's just say I type in an alphabet Y. So here it says invalid input. Please enter a valid number. So as you know, the script checks if the user input is a valid using a regular expression. So if it is, the script prints the number, otherwise it asks for a valid input. Now we shall learn to handle invalid inputs. So you can also provide a default value or prompt to the user to enter valid input unless they provide acceptable data. So I'm going for 23. Is that I'm eligible here. So let me go ahead and execute the same code, but with a different input. Let me say, enter my age 10. So it says that my input was invalid and age must be greater than or equal to. So in this case, the script will keep asking for the age until a valid input, which is a number greater than or equal to 18, is provided. So with these techniques in hand, you will be able to write more robust and reliable shell scripts that can handle errors gracefully and debug them effectively. We shall now speak about advanced shell features. So let's start off with arrays and associative arrays. So in shell scripting, arrays allow you to store multiple values in a single variable, and associative arrays, which are also known as hash, allow you to store key value pairs. These features are useful for managing and organizing large amounts of data efficiently. A regular is a list of items where each element has an index which starts from 0. So you can use it to store multiple values under a single variable name. So I'll go ahead and show you an example. So here we have first defined, and we have a variable name called fruits, and we have 3 different fruits here: apple, banana, and cherry. Then we have a function here to access an element by its index. So let's move ahead and execute this particular code. So as you can see, the item at index value 0 was apple. And here we have got the output as apple. We shall now speak about length. You can get the length of an using the $sign. So this is the line of code for the same in order to get the length. So here we have gotten the output as array length is equal to 3. Now let's learn to loop through an array. So you can loop through an array using a loop to access each element. So for example, so here for the output we have got I like apple, I like banana, and I like cherry. Moving on to associative arrays. Associative arrays are arrays that use named keys rather than numeric indices. So for example, at first you're supposed to declare an associative array, after which you will have to access the values using keys. So let me go ahead and show this to you. So you can also loop through associative arrays using a for loop to access both the keys and values. So before that, let's go ahead and execute the previous code. So now that I've executed the code, I've gotten Alice for the name and 30 for the age. So let's move ahead and loop through associative arrays using a for loop to access both the keys and values. So this is the for key as well as the value. So let me go and execute this. Yeah. So we get the same output as the previous one. Now let's move on to command substitution and arithmetic expansion. Command substitution allows you to capture the output of a command and use it as an input for another command, while arithmetic expression lets you to perform calculations inside your script. Let's now speak about command substitution. So this allows you to capture the output of a command and use it within another command or variable. So it's like saying run this command and use its result here. So for example, the command date captures the current date and stores it in the current date variable, which is then printed. So as you can see, we have the output here, which is the date printed. Let's now move on to arithmetic expansion. So this allows you to perform arithmetic calculations directly in your script. For example, so using this particular code, you're supposed to obtain the sum of two different numbers. So we have inputted the numbers as 5 and 10 into the variables num1 and num2 respectively. So let's go ahead and execute this. So as you can see, the output is returned as the sum is 15. So you can use any basic arithmetic operations such as addition, subtraction, multiplication, and division along with modulo. Let's now move on to advanced arithmetic. You can also perform more complex arithmetic within this particular syntax. So it has been displayed on the screen here, along with which incrementing and decrementing of values can also be done. So we're supposed to get the output as count is 1. Let's go ahead and see how it works. So we have count. We'll have to increment by 1 after that. Yeah. So as you can see, we've obtained the output as count is now 1. So it's shown here. We shall now move on to built-in commands, which are eval and exec. So shell scripting includes several built-in commands that enhance functionality. Two powerful built-ins are eval and exec. So the eval command is used to execute arguments as a shell command. It allows you to dynamically evaluate and run shell commands stored in variables. So here's a small example for the same. So the output in this case is supposed to be hello world. So in this case, the variable command contains a string of a command which is echo hello world. And the eval executes the string as if it were a command itself. Hello world as the output. Now speaking about the exec command. So the exec command is used to replace the current shell with a new command. So when you use exec, it doesn't really create a new process. Instead, the current process is replaced. So this is commonly used to run a program and immediately replace the current script. For example, so once I've executed this, it's supposed to list the files in the current directory, but after the command runs, the shell will be replaced by ls and the script will no longer continue after the point. So here's a small note. Once exec is used, it doesn't return control to the original script. So it's useful when you want to start a new process without returning to the script. Let's now speak about using select for interactive menus. So the select command is a great way to build a simple text-based menu in a shell script. For example, so as you can see, we have 4 options, which are option 1, option 2, option 3, as well as quit. So the select command presents a numbered list of options to the user. So as you can see here, a numbered list has been provided, which has option 1, option 2, option 3, as well as quit. So the user selects an option by entering the corresponding number. The case statement handles the user selection, performing the appropriate action. So if the user selects quit, the break statement exits the loop. So let me go and execute this. I'll go for option 2 first. So it's mentioned that I've selected option 2. Now let's just say the user wants to quit. Yeah. So as you can see, we've exited from the menu. These features enable you to create a more dynamic, powerful, and interactive scripts. So with these advanced tools, you're well equipped to tackle complex shell scripting tasks. We shall now move on to the next chapter, which is on automation and cron jobs. So writing scripts for backup and monitoring automation is one of the key advantages of shell scripting. So with shell scripts, you can automate repetitive tasks such as backing up important files or monitoring system resources. Let's start by writing a basic backup script that copies files to a backup directory. So imagine you want to back up your important documents from a folder documents to a backup folder called as backup. So you can use the cp command to copy files and directories. So I'll go ahead and show you the same. So as you can see here, we have our source directory as well as our backup directory. The script checks if the backup directory exists. If it doesn't, it creates it. So as you can see here, it wasn't existing in the beginning for me. So it went ahead and created a new directory. Then it uses cpr to copy all the files and directories from documents to backup. Finally, it prints a success message once the backup is complete. Backup has been completed successfully. Now let's move on to monitoring usage. You can also automate monitoring tasks. For instance, you can write a script to check usage and alert when yours is nearly full. For example, this is how it typically works. The script uses the df command to get the usage and the output using awk. So the script uses the df command to get the disk usage and parses the output using awk and set to extract just the percentage. It compares the current usage to a threshold, which in this case is 80, and prints a warning if the usage exceeds that threshold. So as you can see here, we have the current usage as 1%, and it's mentioned here that the disk usage is under control. So there are no issues. Now let's move on to scheduling tasks with cron tab. Now that we have written scripts for backup and monitoring, let's automate their execution using cron. Cron is a built-in Linux tool that allows you to schedule tasks to run automatically at specified intervals. So what is cron? Cron is a time-based job scheduler Unix-like operating systems. So you can use it to schedule scripts or commands to run at specific times such as daily, weekly, or monthly. So here's how you can set up cron jobs. So to schedule a task, you use the cron tab command. Each user on the system can have their own cron tab file, which contains a list of commands and the schedule times. To edit the cron tab file, type cron tab e. So this opens your cron tab file where you can specify the schedule for your tasks. Moving on, we have cron job syntax. So the general syntax for a cron job looks like this. So for example, if you want to run a script every day at 3 a.m., you would have to add the following cron job. So this will schedule the backup script to run at 3 a.m. every day. So here are some common cron job schedules. Midnight, run every Sunday, run on the first day of every month. So these can be displayed in the following manner. I can show it to you here. So this is how you run them. Let's now speak about listing and removing cron jobs. So in order to view your current cron job, this is what you're supposed to type. If you want to remove all of your cron jobs, this is the command. Let's take a real-world example of daily system health reports. Let's say we want to automate a daily health report for the system, including disk usage, memory usage, and CPU load. So we can write a script to gather this information and email it to the system administrator every day at 8 a.m. So let's now speak about system health report script. So here's an example script that gathers system health information and saves it to a log file. So typically, this script collects disk usage, memory usage, and CPU load, writes the information into a file, and emails it to the system administrator. So in my system, it says that command mail is not found. So it means that mail hasn't been installed into the system. So here's what you're supposed to be doing. So you're supposed to be using this particular sudo command, which is displayed on my screen, after which you will be asked to enter your password. So following that, you can install mail into your system. So let's now speak about scheduling the script with cron. So in order to run the script every day at 8 a.m., add the following cron job. So you will have to open cron e and then paste this particular line of code into it. So it's this one. Then click on enter. So this particular cron job ensures that the system health report is automatically generated and sent daily at 8 a.m. So with these tools, you can automate a variety of tasks, ensuring that they run at the right time without manual intervention. So whether it's backing up files, monitoring system health, or scheduling regular maintenance, cron jobs help you keep everything running smoothly in the background. Let's now move on to interactive and user-friendly scripts. In many scripts, you may need to gather sensitive information from the user, such as passwords. However, it's important that passwords are not displayed on the screen as the user types it. Fortunately, Bash provides a way to securely read passwords using the read command with the S option. The S option ensures that the input is not displayed on the screen, making it ideal for sensitive information. You will have to enter your password. Then if the password has been read, password entered successfully will be printed. We'll go ahead and enter our password now. As you can see, once the password is entered, the script confirms the action without showing the password. It has been displayed, password entered successfully. Now let's move on to validating the password. Password meets specific criteria. I'll show you a small example for the same. This is the code for the same to check whether the criteria is being met. So in this particular script, we will check if the password length is less than 8 characters. So if it is, we ask the user to enter a longer password. So let me go ahead and type a password which is more than 8 characters. So as you can see, the password has been accepted because I typed a password which has more than 8 characters. But let me go ahead and type a password which is less than 8 characters. Yeah. So here it has been displayed that the password must be at least 8 characters long. So it gets rejected. Now we shall learn to make menus with select and case. So a great way to make your script interactive and user-friendly is by providing a menu system where the user can select options from a list. So this can be achieved using the select command, which presents options to the users and allows them to choose an option by the number. The select command creates a simple menu where each option is assigned a number and the user can choose one by entering the corresponding number. So for example, let me go ahead and execute this particular code. So here's how this code works. The select command displays the menu options as numbers. The user selects an option by typing the number corresponding to their choice. So let me go and choose an option. I'm going to choose 2 over here. So the case statement then processes the user's choice. If the user selects quit, the script will exit. Let's just say I pick 4. Then we've exited from the menu and the script breaks. This approach makes your scripts interactive and easy to navigate. We shall now learn how to use colors and formatting output. In order to make your scripts more user-friendly, you can add colors and formatting to your output. This helps draw attention to important information such as warnings, errors, or success messages. In Bash, colors are applied using special escape sequences. Firstly, we have basic color codes. Here are some common color codes for terminal text. As you can see, we have red, green, yellow, blue, as well as reset to default. Now move on to using colors in echo statements. So you can apply these colors directly in the echo command to color the text output. So I shall show you a small example for the same. So as you can see, these colors have been applied to the echo command to color the text output. So here we have, this is a success message which is in the color of green. And then we have, this is an error message which is in the color of red. The E option allows echo to interpret escape sequences. So in the first case, these numbers and symbols here changes the text color to green, and this particular sequence applies red for error messages. Let's learn another example. So this is colorful menu output. So let's create a simple script that uses colors to highlight different menu options. So for example, this is the line of code for the same. For example, we used color codes to display the menu options in green, yellow, and red. So when the user selects an option, the script outputs the selected option in the corresponding color. So go ahead and test that out. So let me select option 1. So as you can see that the text here is displayed in the color of green. Let's go ahead and select option 2. We have yellow displayed in this case. And if I go for 3, the text is displayed in the color red. Now, if I select the option 4, we exit from the menu. Let's now talk about bold and underline. You can also make the text bold or underline it using additional escape codes. So for bold, this is what we have, and for underline, it's this. Let me show you this with the help of a small example. So as you can see, we have made a text bold and underlined it using additional escape codes. So as you can see here, we have the sentence. This is bold and blue text, which is in the color of blue. And here we have a sentence here underlined. So these features can make your scripts more engaging and easier to use along with visually appealing. By using colors and interactive menus, you can create professional scripts and enhance user experience. Finally, let's talk about real-world shell projects. So in this chapter, we will work through 3 real-world shell scripting projects that you can use. These projects demonstrate how to automate file organization, monitor system health, and even send email alerts. So these are real-world automations. And these can help you become more efficient in managing systems and data. So for the first one, we have folder and file organizer script. As your files accumulate over time, it's important to organize them. So this script helps you automatically organize files based on their file extensions or types. You can classify files into folders like images, documents, and music, making it easier to navigate and manage your system. So here's the objective. Automatically sort files from a downloads folder into categorized folders. For example, images, documents, and music. So here's the explanation for the code. The script first defines directories for storing organized files. It creates those directories using mkdir p to ensure that the directories exist. Then they use mv to move specified file types like images, documents, and music from the downloads folder to the appropriate directories. Finally, it prints a confirmation message when the files have been organized. For the second project, we have disk usage monitor with email alert. Monitoring disk usage is crucial to avoid filling up your disk space, especially on servers or systems with limited storage. So the whole objective of this particular project was to monitor disk usage and send an email alert if it exceeds a defined threshold. As you already know, that script checked for the disk usage on the directory using the df command and extracted the percentage of the usage. It also compared the current usage with a predefined threshold. If the disk usage exceeded that threshold, it sent an email using the mail command with a warning message. And if the usage was within the limit, it printed a message saying everything was under control. I shall mention a small thing over here. You have to ensure that the mail command is configured on your system to send emails. So you may need to install mail and set up a mail server for the same. Let's move on to the third project, which is on server health check automation. It has been implemented in the previous chapters. So in this case, servers often run critical tasks and services, and it's important to keep track of their health. So this script automates a system health check by monitoring essential server metrics such as CPU overload, memory usage, disk space, and network state. So it can also send alerts if something goes wrong. So here's the objective. Automate a health check for a server and generate a daily report with system metrics. So as you already know from the previous chapter, the script collects key system metrics, which is overload, memory usage. So you know that the script will generate a health report and it sends it via mail. So as with the previous project, ensure that the mail command is properly configured to send mails. So these projects are great examples of how shell scripting can save time, improve system monitoring, and automate tasks. By creating scripts like these, you can automate mundane tasks, monitor server health, and ensure that your systems run smoothly with minimal manual intervention. Continuous integration, which is CI, and continuous development, which is CD, are essential practices in modern DevOps pipelines. Shell scripts play a vital role in automating the build, test, and deployment steps in these pipelines. So let's explore how Bash is used to automate tasks within CI/CD pipelines. So shell scripts are often used to automate the build processes in a CI pipeline. For example, when you're using tools like Jenkins or GitHub Actions, you can write a script that installs dependencies, compiles code, and runs tests. So in this particular example, the script installs dependencies with npm install, runs tests with npm test, and builds the project with npm build. Let's now move on to using shell scripts in CI configurations. So CI tools like Jenkins or GitHub Actions allows you to integrate shell scripts into your pipeline configuration files. So for instance, in a Jenkins file, you can add shell steps to the pipeline stages. For example, in this case, the highlighted command runs shell scripts that automate the build and testing phases for CI pipeline. Let's now talk about deployment with shell scripts. So after successful testing, you can use a shell script to deploy the application to a production or staging environment. So here is a line of code which does the same. So this script uses the SCP to copy the build files to server and then restarts the Nginx service using the system CTI to apply the new deployment. Now we shall move on to integrating scripts into Jenkins and Git. So CI/CD platforms like Jenkins and GitHub Actions are heavily used to automate code integration, testing, and deployment processes. Shell scripts integrate seamlessly with these tools to automate various steps. Jenkins allows you to define pipeline stages in Jenkins file. So you can easily execute shell scripts within these stages using the sh command. So this particular pipeline has 3 stages, which is installing dependencies, running tests, and deploying the application, all of which are powered by the shell commands. Finally, we shall learn how to use shell scripts in GitHub Actions. So GitHub Actions allows you to automate workflows directly from your GitHub repository. You can integrate shell scripts in the workflow steps. So let's begin with shell in DevOps and CI/CD use cases. So let's first start with creating a file. So I'll go ahead and do that now. So the name of the file is pipeline.sh. This opens an editor here. Let's go ahead and paste the code. So now that we have the code here, let's go ahead and exit. So you get the option here to save modified buffer. Just click Y and enter. Let's go ahead and give it a permission to run the code. So basically in this section, I was going to demonstrate how Bash is used in the CI/CD pipelines to automate build, test, and deployment stages. So in real DevOps environments, CI/CD pipelines automatically execute tasks wherever the code is published to a repository. So these tasks typically include installing dependencies, running automated tasks, building the project, deploying the application being the last step. So to demonstrate this safely without external tools like Jenkins or GitHub Actions, I've created a local simulation script called pipeline.sh. So the script mimics how a real CI/CD pipeline operates. So the script defines three main functions here. So there's build, test, and deploy. As you can see, there's build, test, and deploy, along with which it also creates a build artifact file called buildartifact.txt. We also have a log file called pipeline.log. So each stage logs its execution with timestamps. So this reflects how real CI systems maintain traceability and logs. So now I'll go ahead and execute the build stage. So since I have not created a build artifact file, let's go ahead and create that first. So I'll use the touch command, build artifact. We'll also go ahead and make a log file called pipeline.log. So now I'll execute the build stage. So it's /pipeline sh build. So as you can see, the build artifact has been confirmed. So this particular stage simulates installing dependencies, running validation checks, and building the project. So at the end, it creates a file named buildartifact.txt. So in real CI systems, this would represent compiled code or a container image. So the script also logs the successful build into pipeline.log. And this demonstrates artifact creation and logging. Now let's demonstrate the test stage. I will now execute the test stage. /pipeline.sh test. So as you can see, all the automated tasks have been run and all the tests have passed successfully. So this script basically checks whether the build artifact exists or not. So if the build file is present, the test passes, or if the build file is missing, the test fails and the script exists. So this demonstrates stage dependency. In real pipelines, deployment is blocked if the testing fails. Let's go ahead and demonstrate deployment stage. Now I will execute the deployment stage. As mentioned, the deployment has been successfully completed. If validation succeeds, it simulates preparing deployment, deploying application, and restarting services. So if the build artifact does not exist, the deployment fails. This mirrors real-world CI systems where deployment depends on successful and tests. Now I will go ahead and execute the complete pipeline. So go ahead and do that now. This runs build, test, and deploy sequentially and automatically. So this simulates how platforms execute pipeline stages after a code push. So here, each step depends on the previous one. If any stage fails, the execution stops. Finally, I will display the log file. So this file contains the timestamped entries for build completion, test results, and deployment status. So logging provides audit trails, debugging information, and execution history. So in enterprise environments, logs are centralized using monitoring tools. Here, we simulate that observability locally. Now I shall explain integration with Jenkins and GitHub Actions. So in tools like Jenkins, pipeline stages are defined in Jenkins file. Each stage runs shell commands using the sh instruction. So for example, let me go and type out the line of code that I'm talking about here. So that will be /pipeline. So similarly, GitHub Actions executes shell commands using the run directive. The orchestration tool manages triggers and scheduling, but shell scripts perform the core automation work. So this script represents that execution layer. In DevOps environments, Docker is widely used to manage containerized applications. Typically, we build images, run containers, stop them, and remove them using Docker commands. However, to demonstrate the core automation logic without relying on Docker installation, I have created a lightweight shell script that simulates the Docker container lifecycle. So this allows us to understand the concept of container management purely through scripting. mockdocker.sh. This script accepts arguments such as build, run, and status. So internally, instead of creating a real container, it uses a simple file to represent the container state. So if the file exists, the container is considered running. If the file does not exist, the container is considered stopped. This simulates how Docker maintains container state. So now I'll go ahead and demonstrate the workflow. So the code within mock Docker is as follows. Let me go and exit from the editor. Save it. Make sure you always save the contents within the editor first. Okay. So now I will go ahead and demonstrate the workflow. So first I simulate building an image by running the following command. So /mock says the permission has been denied. So let's go ahead and give it permission X and then mock docker.sh. This should be fine now. Let's go ahead and run the code again. Yeah. So as you can see, in a real Docker environment, this step would build an image from a Docker file. So here the script simply prints a message indicating that the image has been built successfully. This represents the build stage in a DevOps pipeline. Next, I simulate running a container. So the command for that is /mock container.sh, and then you just run it. Yeah. So this command creates a file that represents a running container. So in Docker, the docker run command starts a container instance from the image. So in this simulation, we replicate the behavior using file creation. Now let me go ahead and check the container status. So for that, I will have to do /mock. Yeah. So this script verifies whether the container file exists and print the current state. So this is conceptually similar to using Docker inspect or Docker PS. So this is done to ensure whether a container is active. So next, I simulate stopping the container. Yeah. So this removes the file representing the container. In Docker, the docker stop command stops the running container process. Here we simulated that behavior by removing the state file. Finally, I check the status again. So let's go ahead and do that. Yeah. So the script confirms that the container is no longer running. So through the simulation, we have automated the following container lifecycle stages. So there's image build, container start, status monitoring, and container stop. So even though this is a simplified implementation, it demonstrates the fundamental DevOps principle of automation through scripting. In real-world environments, Docker commands would replace these simulated operations, but the underlying logic of lifecycle management remains the same. So this completes the demonstration of container lifecycle automation using a shell-based simulation. Let's now move on to automating system monitoring using shell script. In DevOps environments, monitoring is a critical responsibility. Teams continuously monitor system resources such as CPU usage, memory usage, and service availability to ensure stability and performance. Automation is used to detect issues early and trigger alerts when thresholds are exceeded. So this demonstrates the concept. I have created a simple shell script that monitors CPU and memory usage. This script simulates how monitoring tools work in real DevOps pipelines. Script retrieves CPU usage using the top command, and it retrieves memory usage using the free command. So these are standard utilities commonly used in server environments. So let's go and create a file called as monitor.sh. So let's open the editor, monitor. Let's go ahead and paste the code. Always make sure to save the contents within the editor. And then enter. So now I will go ahead and run the monitoring script. It says permission denied. So let's go ahead and give it reading permission. So now when I execute this, the script displays the current CPU usage and the memory usage percentage. So in a real production setup, this data would be collected continuously and sent to the monitoring systems such as Prometheus, Grafana, Nagios, and cloud monitoring tools. So here we're focusing on the core logic behind monitoring. So the script also includes a conditional check. If the CPU usage exceeds a defined threshold, for example 80%, it displays an alert message. So this demonstrates how DevOps teams implement automated alerting mechanisms. So instead of manually checking the servers, automation ensures that the system notifies engineers when resource consumption becomes critical. So this particular example highlighted 3 key DevOps principles, which is automated system monitoring, resource threshold checks, as well as proactive alerting. So even though this is a simplified script, it reflects how infrastructure monitoring works at a conceptual level. So in enterprise environments, similar logic runs continuously in the background to maintain system health and availability. Yeah. So all the simplified scripts reflect the foundational logic behind modern DevOps tools. So the tools may vary, but the automation principles remain constant. So this completes the demonstration of automated system monitoring using shell scripting. You've just taken the first step into a skill that quietly powers a huge part of the computing world. Shell scripting isn't about memorizing commands, it's about thinking clearly, simplifying work, and letting the computer help you. The more you practice, the more natural it becomes. As you go through this course, don't worry about getting everything perfect. Focus on understanding why things work. Curiosity beats speed every single time. If this session helped you, feel free to like, comment, or share your thoughts. Tell us what you're excited to build or what confused you. Questions are always welcome. Now take a deep breath, open your terminal, and start experimenting. One script at a time, you're building real confidence. Happy learning and happy scripting.